Exercise 4H, question number 11. A genetic condition is known to be present in 4% of population. A test is developed to help find whether or not someone has the genetic condition. If a person has the condition, the test is positive with a probability of 0.9, and if a person does not have the condition, the test is positive with a probability of 0.02. Part A says draw a tree diagram to represent this information. So the first part of the question says that the possibility of a genetic condition being present is 4%. So let's write, if we have a tree diagram, the probability that a genetic condition is present is 4%. So 4% will be 0.04 in terms of probability. Therefore, the probability that the genetic condition is not present, G complement, which is not present, will be 1 minus 0.04, which is 0.96. Moving forward, a test is developed to help find whether or not someone has the genetic condition. If a person has the condition, the test is positive with a probability of 0.9. So now, the test is developed to find whether or not a person is positive. So if a person is positive, it's going to be P, and not positive, it's going to be P complement. So if a person has the condition, so these are the people who have the genetic condition. So if a person has the genetic condition, the test is positive with a probability of 0.9. So for the people who have the genetic condition, the test is positive with a probability of 0.9. So this is going to be 0.9. Therefore, the probability that the test is negative or not positive will be 0.1. So this is going to be 0.1. Then if a person does not have the condition, the test is positive with a probability of 0.02. So these are the one who do not have the genetic condition. Then for these, the test is positive with a probability of 0.02. So let's complete the tree diagram. The test is positive. The test is not positive. So for those who do not have the genetic condition, the test is positive with a probability of 0.02. 1 minus 0.02 is 0.98, and that is the probability of not being positive. So that answers part A, which says draw a tree diagram. Now in part B, a person is selected at random from the population and tested for this condition. Find the probability that the test is negative. So we need to find in general that the test is negative. The test is negative here. P complement means not present or negative, and the test is negative here. So for those who have the genetic condition and their test is negative, and for those who do not have the genetic condition and their test is negative. So for B, we have 0.04 into 0.1 and 0.96 into 0.98, and that gives us the answer 0.9448. So this was in general for those for whom the test was negative. Once again, for those who have the genetic condition but the test turned out to be negative, so they are here. And for those who do not have the genetic condition, and for them the test turned out to be negative, and they are here. So when we add the probability, this option or this option, we get the answer here. That was B. Now we move on to C. A doctor randomly selects a person from the population and tests for the condition. Given that the test is negative, find the probability that the person does have the condition. So this is the conditional probability given that the test is negative. So in general, the test is negative. Find the probability that the person does have the condition. So we want to have the genetic condition and the test is negative. Given that test is negative. So we know that in conditional probability, this is our denominator. We have already found in general the probability of test being negative, and that is 0.9448. So that's going to be our denominator. So 0.9448, because this part of the conditional probability is our denominator, and the probability of the test genetic condition being present and the test being negative. So the genetic condition being present and the test being negative is 0.04 into 0.1, and that's our numerator. 0.04 into 0.1, and when we work this out, we get the answer as 0.00423, and that answers for B. Now for D, the question says comment on the effectiveness of this test. Now when we observe the test, we see that there are those who have the genetic condition. So these are those who have the genetic condition, but sadly their test turned out to be negative. And at the same time, we have those who actually do not have the genetic condition and whose test turned out to be positive. So now from all of those who actually had the condition, 10% were tested as negative. So from those who actually had the disease, 10% of them, in spite of having the disease, they were tested as negative. And from those who did not have the disease, 2% tested as positive. So this tells us that the test is not effective because it's giving us incorrect results to some extent.